In this video, I'm gonna go through some circuits problem. I will discuss series and parallel and complex circuits. In my previous video on Kirchhoff's voltage and current laws, we derived the following formula for series and parallel circuits. Right now, let's go through some examples. The first example, as you can see, we have two resistors. They are one after another. So it means it's a series circuit. What we need to find here, the question asks us to find R total, first step. So firstly, this one is V total. And we want to find our R total. And as we know, these two resistors are in series. So we know the formula for series circuit is R1 plus R2. So it's equal to 2 plus 2 equal 4 ohms. Right now we have our R total and we have our V total. We use Ohm's law formula to find R total. So V total equal R total times I total, which is equal, just I substitute number here, 12, 4, and as a result, our I total equal to 3 amps. Okay. The next part of the question asks about finding I1. So we have this one now. We have this one, I1 and I2. As we know, when we talk about the series circuit, I total is equal I1 equal I2 equal IN. The reason for this is explained in my previous video when I explained Kirchhoff's current law. So I total equal I1 equal I2. So it means I total is 3 amps. So it's equal I1 is equal I2. So it means I1 and I2 both are equal 3 amps. And so we have this one now, we have this one. Right now we want to find V1. Again, we use Ohm's law formula that V1 equal R1, I1. And so R1 is 2 ohms as is given to us here. And I1 is 3 amps, so it's 6 volts. We do the same things for V2. So V2 again equal R2, I2. So it's 2 times 3, 6 volts. As you can see, V1 plus V2, V1 plus V2 is equal 12 volt. That is equal our total voltage. Let's go through the second example. The second example, as you can see here, we have again two resistors, but these two resistors are in parallel. See, we have two loops. One loop is for resistor number 2, and one loop is for resistor number 1. So they are in parallel. Let's see what we need to find here. The question asks us to find R total. Okay. For finding R total, let's see what we have. Definitely we have the voltage of battery, that is our V total. So we have V total. We don't have our R total, but we can find that one. Which formula we need to use? Because they are in parallel, so we use 1 over R total equal 1 over R1 plus 1 over R2. And both resistors are 3 ohms, so just simply 1 over 3. So 1 over R total is 2 over 3. So as a result, R total is 3 divided by 2 equal 1.5 ohms. Okay, we have V total, we have R total. Just we need to use Ohm's law to find I total. So I total is equal 8 amp if I don't make mistake. Okay, and also the question, so we found I total, and the question asks us to find I1. Okay, for I1, okay, we see we have R1, that is 3 ohm. We don't have I1, but we have V1, because we know when we have a parallel circuit, V total is equal V1 equal V2. So we know our V total is 12. So as a result, we know our V1 also is equal 12 volts. So I write again, I use Ohm's law, V1 equal R1, I1. We know V1 is 12 volts, R1 is 3, I1. So as a result, I1 is equal 4 amps. Let's go through other example. This example is a complex circuit. It means that we have both series and parallel resistors. So we can't put it in category of series or parallel. Let's see how we can approach this type of question. As you can see, I have R1 that is in series with all this part. So R1 is in series with this part. I want to name this part, for example, R dash. So if I look at R dash, I can see inside that I have R2 and R3 that they are in series. So I want to name the sum of these two as, for example, R double dash. Okay. And R double dash is in parallel with R4. Just I write step by step how we can solve this problem. So if I want to find R double dash, R double dash is R2 plus R3. Why? Because these two are in series. And all our resistors are 2 ohm. So it's equal to 2 plus 2, 4 ohm. R double dash is in parallel with R4. And I name the sum of these two as R dash. So I can write 1 over R dash equal 1 over R double dash plus 1 over R4. So we write it like 1 over 4 plus 1 over 2, which is equal okay. Right now we have R dashed here, and we know R1 and R dash are in series. And if we find the sum of these two, it means actually we found our R total. So I write R total equal R1 plus R dash equal 2 10 divided by 3 ohms. Okay, right now we need to find our I total. So as usual, we say V total equal R total times R total, sorry, I total. V total is equal 12 volts. R total, just we found it, 10 divided by 3, and I total is something that we want to find. So as a result, I total is equal to 3.6 amps. Okay, so we have right now our I total. What else we need to find? We need to find our I1. And as you can see, I total, if I go from positive conventional current, I total going through circuit enters this junction, I total enters here, and going to two branches, coming here, and again getting out here, we have again I total, Kirchhoff's current law. And then I total goes into R1, and again, as the law of conservation of charges, the current here also should be equal I total. Or we can say R1 is in series, so current for I1 is equal I total is equal 3.6 amps. And also we need to find I4 and I2. To find R4, we look at our circuit one more time. I want to draw it in a simple form. So I can say this one is R1, and then this one is R double dash, and this one is R4. Okay, and R double dash, as we already talked about, that was sum of R2 and R3. So the voltage drop for R double dash and R4 are equal. So if I use Ohm's law for both of them, I can say V double dash equal V4 because they are in parallel. And also I can say R I4. So as a result, I can write it this way. I4 to I double dash is like R double dash to R4. And we already found R double dash that was equal 4. We know our R4 is 2, so it's equal 2. Okay, as a result, it means I4 to I double dash equal 2, I4 is equal to I double dash. And also we know the total current going inside these two loops, and then between two, they just divided between these two branches. But if I name this one I4, and if I name this one I double dash, we know the sum of these two should be equal IT according to Kirchhoff's current law. So I write it here. Also, we know I double dash plus I4 is equal to 3.6 amps, as we found it already. So, and also we know I4 is 2I double dash, so I write I double dash plus 2I double dash equals 3.6 amp. As a result, I double dash is equal to 1.2 amp, and I4 is equal 2.4 amp. And we have I4 equal 2.4 amp. We need to find our I2 and V1. Okay, so we go to next step, that is I2. Just I answer it here. For I2, we know I double dash going through R3, and then I in should be equal I out, and then going out, and then I, that is, so I double dash going inside R3, and then the same I going out, because I in should be equal I out, and then I double dash go inside R2, and then going out again. What does it mean? It means I3 and I2 both are equal R double dash that we found it here. So I2 is equal 1.2 amp. The last part of the question is finding V1. Okay, V1 is equal R1 times I1. And we know I1, we already found I1. And we know R1 is equal 2 ohms. So 2 times 3.6. So it's equal 7.2 volts. Let's go through one more example of complex circuits. We look at this one, and again, we want to see how we can make this circuit simple. Something that we need to find here, definitely we need to find R total. We need to find the number here, what voltmeter shows here, what ammeter shows here, and ammeter shows here. So this one actually shows I total. This one shows, if I name this one R1, name this one R2. So this one shows V1. I name this one R3. So this one shows I3. Okay, let's see how we can solve this problem. The first step, again, for solving this problem is to simplify our circuit. Let's look at this. If I consider these two as one, it means finding the sum of these two. Let's see what happens. If I do this one, I have one resistor. And if I name this one, for example, R dash, this one is R4, R5, R6, and R7. This one is R dash. And this R dash is the sum of R6 and R7. And then I have R4 and R5 again in series, and I find the sum of these two. And let's say I name this one R double dashed, and I put it here, R double dashed. And then I have R3 here that is in parallel with R dashed and R double dashed. So I put R3 here, okay. And we see these three are in series with R1 and R2. Okay, just I draw R2 and R1. I don't draw a whole circuit, just my focus is on resistors now. So I have R1, R2, and these three in parallels now. Then if I want to make it simpler, I can just say these three that they are in parallel. I can easily find the sum of that. And I want to name this one R triple dash. So I can, after that next step, I can say, so this is R triple dash that is in series with R2 and R1. Okay. So how can I solve this problem? So it means if I want to go step by step, firstly, I need to find R1 and then R double dash. and I have R3, then I find R triple dash. So I go step by step. Step 1, 2, step 3, and then step 4 is to find the sum of these three as R total. Let's start. So firstly, I say R dash. That is R dash, as we define that here, is sum of R6 and R7. R6 and R7 are in series, so just simply R6 plus R7. That is 2 plus 2, 4 ohms. And R double dash is equal to, R double dash is sum of the R4 and R5 that again they are in series, R4 plus R5. It means 1 plus 2, 3 ohm. So tick off this one, we've done it. We've done this one, and we have R dash, double dash, and we have R3 here. Right now we can find our R triple dash. And because these three are in parallel, so we use the formula for parallel circuit. So I write 1 over R triple dash, that is sum of these three, equal 1 over R dash plus 1 over R double dash plus 1 over R3. Just I substitute number. Is 19 over 12. As a result, R triple dash is equal 12 divided by 19 ohms. So right now we found this one. So right now we have R triple dash, R1 and R2 given to us, and we see these three are in series. And if we add these three, we can find our R total. Okay, so I write R total actually is equal R1 plus R2 plus R triple dash, because they are in series. So it's equal to, just I substitute number that we have here. Okay, so we have R total, and the question asks us for I total. Easily we need to use Ohm's law again. And I substitute number, V total is 24 ohms as is given to us here. So I total equals 6.61 amp. And then also the question asks us to find V1. We see I total, this is I total, and I total going through R1. We know I in should be equal I out. So I total going out is equal R1. So for V1 is R1, I1, and I1 is equal actually I total because it's in series. So it means voltage drop for first resistor is equal to 6.61 volts. The other things that we need to find is I3 for this one. To find I3, we need to find firstly V3. How we can find it? We know V total actually is equal V1 plus V2 plus V between these 2 points. So we need to find V between these 2 points. But to find this one, we need first to find V2. Finding V2 is not difficult, just we need to write R2, I2. R2 again is in series, so the current of R2 is equal I total, is equal 6.61 amp. And it's equal 13.22 volts altogether. So right now we know voltage of V3 is equal to the voltage between these 2 points. V3 actually is equal 24 minus V1 minus V2. So as a result, is equal to 10.78 volt. V3 is equal R3I3, and just I substitute number. One ohms, and we can find I3 equal 10.73 amps. I hope you found this video helpful, and thank you for watching.